Hello friends, so in this session I am going to discuss about the numerical problems on these spark gears on length of path of contact, length of arc of contact, contact ratio and the sliding velocity. Let's see what is the length of path of contact. Length of path of contact is the sum of length of path of approach and the path of recess. For example, in this figure you can see the length of path of contact is K to L. Okay, K to P is a path of approach and P to L is a path of recess. The equation is the path of approach equals square root of RA square minus R square cos square phi minus R sin phi, where here it is a capital RA is a addendum circle radius and R is the pitch circle radius of the pinion, gear, and small letter RA and the R represent the corresponding values of the pinion, that is addendum circle radius of the pinion and the pitch circle radius of the pinion, and phi is the pressure angle. This is the pressure angle. Okay, then the length of arc of contact is the ratio of length of path of contact to the cos phi. Then the contact ratio is the length of arc of contact by the circular pitch. Circular pitch is equal to pi into d by 2 or pi into module, since module equal to diameter by number of teeth. Then angle turned through by the pinion is the length of arc of contact into 360 degree divided by circumference pinion. Then sliding velocity equal to omega 1 plus omega 2 into, that is angular velocity of the pinion plus angular velocity of the gear into km, that is length of path of contact. Okay, then velocity ratio is the velocity is equal to, it is defined as the ratio of the angular velocity of the follower to the angular velocity of the driving gear. Okay, that is velocity ratio equal to angular velocity followed to the angular velocity of the driving gear. Okay, omega 2 by omega 1 or n2 by n1, or it is d1 by d2 or the t1 by t2, since pi d1 by n, pi d1 n1 equal to pi d2 n2. Okay, and module equal to d by t. Module is constant for both the driving and the driven gears. Here n1, so 1 is for the driving and n2 is for the driven, the follower, driver and the follower. Then gear ratio equal to t by t. Okay, pitch line velocity equal to omega 1 into r or omega 2 into capital R. Let's solve the problem. Okay, the first problem, the following data relate to a pair of 20-degree involute gears in mesh. Module is 6 millimeter, the module, the gear 6 millimeter. Number of teeth on the pinion is 17 and number of teeth on the gear is 49. Addenda on the pinion and the gear wheel is 1 module. Addenda constant for both gear and pinion, this 1 module, that is equal to 6 millimeter. Find number of pairs of teeth in contact, that is the contact ratio. The angle turned through by the pinion and the gear will, when one pair of teeth in contact, and the ratio of the sliding to rolling motion, so when the tip of the tooth on the gear, larger wheel just making contact, so leaving contact and at the pitch point. Okay, so we'll solve one by one. First is number of pairs of teeth in contact. To find the number of pairs of teeth in contact, it is equal to your arc of contact into 360, it is contact ratio equal to arc of contact divided by circular pitch. Okay, to find the arc of contact, you should find the length of path of contact. To find the length of path of contact, you should calculate the number of radius, pitch circle radius and the addendum circle radius. So number of pairs of teeth in contact. Okay, so pitch circle radius equal to r equal to mt by 2, that is m is 6 and t is 17 by 2, it is 51 millimeter. Then the pitch circle radius is of the gear, it is capital R. Capital R is equal to m into capital T by 2, that is 6 into 49 by 2, that is 147 millimeter. Then radius of the addendum circle radius, so the addendum circle of the pinion, that is RA equal to R plus addendum is 6 millimeter, it is 57 millimeter. Then the radius of the addendum circle of the gear, it is capital R equal to R plus addendum, it is 153 millimeter. Then the length of path of approach is equal to square root of capital RA square minus R square cos square phi minus R sin phi. Here all the values are known, calculated. Okay, RA and R calculated. Cos phi, the phi is given 20 degree, therefore it is a 15.5 millimeter is the length of path of approach. Okay, then length of path of recess. Okay, path of recess, the length of path of recess is PL equal to square root of RA square minus R square cos square phi minus R sin phi, that is equal to the 13.41 millimeter. Length of path of recess is 13.41 millimeter. Therefore length of path of contact equal to 28.1 28.9 millimeter. That is sum of these two, sum of these two, 15.5 and 13.4. That is the length of path of contact. Then calculate length of arc of contact. It is the ratio of length of path of contact divided to the cos phi, that is 28.91 divided by cos 20, that is 30.8 millimeter. The circular pitch is equal to pi into module or pi into d by t or pi into module. It is 6, that is 18.85 millimeter is the circular pitch. Then number of pairs of teeth in contact equal to length of arc of contact divided by circular pitch. Okay, length of arc of contact is 13.8 divided by circular pitch is 18.8, so it is 1.6. 7.6 is nearly, and that is it should be the your contact ratio always it should be the full number, therefore it is 2. Okay, contact ratio is 2. Next the second point to calculate, that is the angle turned through by the pinion and the gear wheel. So when one pair of teeth is in contact, angle turned by the gear and the gear, so you have to calculate the pinion separately. Okay, gear and pinion you have to calculate. So okay, that is equal to length of arc of contact is 360 degree divided by circumference of the pinion circumference is 2 pi r. Okay, 30.8 length of arc of contact in 360 degree divided by 2.51, that is 34.6 degree angle turned by the pinion and the gear. So pinion, so when one pair of teeth is in contact, that is 34.6 degree, so it will turn 7, so one pair of teeth in contact. Then similarly the angle turned to by the wheel. Okay, so for the when one pair of teeth in contact, it is a circular length of arc of contact divided by 360 circumference of the gear. Gear circumference is 2 pi into radius. Okay, radius of the circle radius. Okay, it is 147, that is 12 degree. Okay, 12 degree. Okay, that is the second point of the second question. So calculated. The first one is your the contact ratio, second is angle turned by the gear as well as the pinion, separately you have to calculate. The denominator should be circumference of the pinion and circumference of the gear. Then the ratio of the sliding to rolling velocity. Okay, ratio of the sliding to rolling velocity, motion or the velocity, since the speed is not given and the omega and omega 1 or the omega 2 is not given, so to find the sliding to rolling velocity. Sliding velocity is nothing but omega 1 plus omega 2 into the omega 1 plus omega 2 into the length of path of contact, whereas the rolling velocity is so VR, rolling velocity, the velocity of the at the pitch line. Okay, linear velocity, it is equal to omega into r, omega into radius. Okay, therefore omega 1 is angular velocity of the pinion and omega 2 is angular velocity of the gear. Here assuming that the pinion drives the gear. Okay, that is the assumption. Omega 1 by omega 2, so I think initially we discussed omega 1 by omega 2 equal to t by t, that is capital T by t, that is reverse of this. Okay, omega 1 is for the pinion and omega 2 is for the gear, therefore it is capital T by t, or omega 2 is equal to omega 1 into t by t, therefore it is 0.347 omega 1, that is omega 2 is represented in terms of the omega 1. And rolling velocity Vr is equal to omega 1 into r or omega 2 into r. Okay, capital R, so that is equal to omega 1 into 51. Okay, 51 omega 1 is the rolling velocity. Okay, rolling velocity, so is 51 omega 1. So therefore here omega 1 plus omega 2 equal to omega 1 plus omega 1 plus 0.347 omega 2 is 0.347 omega 1 into so this ratio will calculate. Okay, Here, at the instant when the tip of the tooth on the larger wheel is just making contact with its making teeth, that is at the beginning of the contact. So the sliding velocity is omega 1 plus omega into kp, that is path of approach. Path of approach here it is 15.5. Okay, omega 1 plus 0.347 omega 2 is 0.347 omega 1 is equal to 20.88 omega 2, sorry, omega 1 millimeter per second. And the denominator, so the rolling velocity is constant for both pin and the gear at any point. Throughout the motion it will be constant. Okay, 51 omega 1, that is omega 1 into r or omega 2 into r, that is 51 into omega 1, 51 into omega 1. Therefore the ratio of these two is equal to vs by vr equal to 0.41 is a ratio of the sliding velocity to the rolling velocity. So that is at the beginning of the contact. Next, at the end of the contact, it is equal to, you have to multiply with the path of recess. Okay, path of recess here it is 13.81. Okay, 13.41. 13.41 is of GL. Okay, omega 1 plus 0.347 omega 1 into 13.41, that is 18.1 omega 1 millimeter per second. Therefore ratio of sliding velocity to rolling velocity is vs by vr is equal to, at the end of the contact, 18.1 by 51, that is 0.355 is a ratio. Next, so third is at the pitch point. Since the pitch point, the sliding velocity is 0. Always the sliding velocity of the pitch point is 0. There is no displacement. Okay, so therefore, so the ratio of the sliding to rolling velocity, it is a 0 only. It is a 0. Okay, this is about the slide your length of path of contact, or so 3 points are to be calculated. One is the sliding ratio of the sliding to rolling velocity. Then second one is the contact ratio. Third third point, so we calculated the angle turn through the pinion. Okay, these are the 3 points so we calculated.